In this video, I'm going to talk about velocity time graphs. Velocity time graphs. So before I talked about distance time graphs, now velocity time graphs. So what's velocity? Well, we know what speed is. Speed is just basically how fast you're moving in a certain amount of time. And we call this in physics a scalar quantity. Scalar means it's just a number. Okay, it doesn't have anything else latched onto it. It's just a number. So let's say 50 k's per hour. It's just a number. Velocity, we call this a vector quantity in physics. Vectors are really important in things like navigation. As a aviator myself, recreational pilot, vectors are used all the time, not just in the air, but also on the ground, boats, etc. Really important things like wind velocity, aircraft velocity. And velocity is basically just speed, but with a direction. So let's say it's 50 k's per hour northwest. Let's suppose there's a wind coming in at 50 k's per hour northwest. Okay, that's a vector. It's got a direction. Something with speed and direction. Something with a vector in general terms is something with magnitude. Magnitude is just size and direction. So in this case, size is 50 k's per hour and direction is northwest. Mathematically, velocity v is the change in your distance over the change in time. Distance could be, let's say, meters or kilometers. Time, it could be seconds or hours. Velocity is typically measured in meters per second or kilometers per hour. And same thing with the speed, distance, time formula. You can draw a triangle. V dt. That's divide, that's multiply. To find distance, you just do v times t. So you cover d with your thumb and you go v times t. To find t, you cover t and you go d divided by v. And so on and so forth. And that's velocity. So what's a velocity time graph look like? Let me draw a graph here. Okay, let's have time at the bottom in, let's say, seconds. Let's have velocity here in meters per seconds. Let me draw a graph like this. Okay, what does this graph mean? Well, start off with the easiest segment. So let's break this graph up into three segments. There's one here, there's two here, and there's a second one here, and there's a third one here. That second one here, that indicates constant velocity. Constant means same, it's not changing. If you read it off the graph, let's suppose it's 50. Let's say there's a car moving along the road. It's traveling at constant velocity. It's, let's say, for like 10 seconds here. 50 meters per second in this case. So that's constant velocity is represented by a flat line, horizontal line. Whenever you have a line like this, a slope, that indicates acceleration. The car is accelerating. And whenever you have a negative gradient, a negative slope, that indicates deceleration. Okay, the car is slowing down. Okay, why is that the case? Because acceleration is an indication of changing velocity. So the velocity of the car is changing here along this slope and along this slope. And this will lead me into acceleration time graphs. So let me draw three sets of axes like this. Let's put time at the bottom. Remember, always typically the case in physics, unless otherwise specified, time is typically at the bottom on the x-axis. Okay, it's the thing that's changing, the independent variable. The independent variable in any experiment, any scenario, is the thing that's changing. So time is changing, right? Acceleration, call it A up here. And I'll show you a series of curves. Okay, I'm not going to put any numbers along these axes. Just going to keep it simple for now. But I'll explain what's happening here. Okay, suppose you got these three graphs. What's happening in the first one? Well, once again, a horizontal line in graphs of motion indicates something that's constant. In this case, constant acceleration. Okay, it's not really changing. The acceleration is staying the same. Let's suppose it's at 50 meters per second squared. And I'll talk about what this is later on, the units for acceleration. This line here, the slope, let's say at 45 degrees, that's uniformly increasing acceleration. Okay, there's acceleration happening here because of the line going up like this. Last one, this indicates non-uniform acceleration. What does that mean? Well, it means that the acceleration isn't constant, it's changing, okay, rapidly here, let's say. It's like an exponential curve. It's a curve that's got a really sharp peak, a really sharp slope here. Right, so it's a changing acceleration. And these are the three typical graphs for acceleration time. And that leads me into into acceleration. So what's acceleration? Acceleration is basically the change in velocity over time. Okay, so there's a change in how fast you're going with respect to time. So mathematically, it's really change in velocity over time, change in time. Okay, we give the symbol A for acceleration in physics. Time is just, so change in, this is, because physicists are really complicated people, including me, we give the symbol delta. This is capital delta. It's like a triangle, and the right side of it is shaded in. So if I can draw it properly. That means change in, because physicists, we're lazy, we're sloppy people. Make things easy. Instead of writing change in all the time, we write it like this. T for time. Change in velocity, that's the numerator, on top of the fraction. Delta, lowercase v. Okay, and I'll clean it up a bit. Looks like this. It's a very simple formula, just like speed, distance, and time. Velocity, distance, and time. It's really the same thing. And you can draw a triangle, of course, as well. To find v, just do a times t. To find a, just do v divided by t. To find t, just do v divided by a. And I'll often get asked this a lot by my students, why are the units for acceleration meters per second squared? Well, let's work this out. What are the units for velocity? Well, we know that it's meters per second. So that's on the numerator. The denominator, time, is measured in seconds. So if you look here, meters per second, which is just meters per second. So writing it like this, that's the same thing as writing it like this. Okay, so they're the units for acceleration.